Okay, the rest of this chapter really focuses in on circles. So that's what the next two sections are that we're going to cover this week. So today we're looking at circles and arcs. A circle, by definition, is the set of all points equidistant from a given point called the center. So I just want you to think about that definition for a second, because that actually, if you think of the tool that we use to draw a circle, that's where this definition comes from. That tool is called a compass, and the compass keeps it so that it's the same distance all the way around to draw the circle. So it's just important that you understand that that's what it means to be a circle, is that we're staying the same distance all the way around. So we're going to look at a couple of the different parts of circles in this next one, and I'm going to color code a little bit. So diameter is a segment that goes through the center with endpoints on the circle. So BD here would be a diameter. And then there's another one. CF is also a diameter because it goes all the way through the circle and passes through the center. The radius is the next one. The radius is a segment with endpoints at the center and on the circle. So that is something like AE. AE is considered a radius. Excuse me. Another radius would be like AC. There's a lot of them up there. Pretty much A and any other point that's on the circle would create a radius. So that's what a radius looks like. And then the last thing I need to understand is what it means to be a central angle. A central angle is when you have an angle whose vertex is at the center. So something like BAF right now. Angle BAF is considered a central angle because the center, the vertex, the center letter, is A, and that's at the center. So that center is in the middle. Okay? So what we're talking about today is the different kind of arcs you can find in a circle. An arc is that curvy part on the outside here of the circle. So that green I just added to the picture, that's what we're considering an arc. There are three different types of arcs we're going to talk about. The first one is a minor arc. A minor arc is an arc whose measure is less than 180 degrees. So an example of a minor arc, when we name minor arcs, you're going to use two letters. And then something would be like arc CD would be a minor arc. Arc DE is also a minor arc. Those are less than 180. So anytime it uses two letters, that's always going to be a minor arc, and they're always going to want you to go the quickest distance from C to D. So I'm going that way to go from C to D. I'm not going all the way around. They're going to use three letters if they want you to go all the way around. So you just need to get in the habit of, if it's two letters, that's the minor arc. It's the shortest distance between those two letters. To find the measure of the minor arc, the measure of the arc is equal to whatever the central angle is. So if I threw like a 40 degrees in here, this arc outside here would be 40 degrees. That's all that means. A major arc is when the arc is more than 180 degrees. So this is now when we're looking at something that goes past the halfway point. So an example of a major arc, if I go the other way here, if I go all the way around this way, what they have to do is they have to use three letters to name it. So you'll see that we'll use three letters. It'll start with the end point still, but then it's going to have a stopping point in the middle, and then it'll tell you where the other end point is. So CBD is one name for that red section. You could also call it CFD, CED. The end letters won't change, but the middle letter has to be one of the points that's on the arc you're trying to name. Another major arc, just to name another one in the picture, let's say if we started at E, E, F, C would also be a major arc. Again, we're going to use three letters when we do major arcs. To find the measure of the major arcs, if you think about specifically that red one there, I could find that by doing 360 degrees minus the minor arc. I'm using 360 because that's what a whole circle has to equal. So I could find that red section by doing 360 minus the part that we don't want, which was the 40, and you would get that that's 320. And we're going to practice that more on the next page. But that's how you find the measure of a major arc. You can do 360 minus its minor arc, the one that you don't want. And then the last one we're looking at is a semicircle. A semicircle is an arc whose endpoints are on the diameter. It's also half a circle. That's the not fancy definition of it. So an example of a semicircle, you will use 3 letters when you name a semicircle as well. So an example of a semicircle in the problem would be CBF. That's a semicircle. Or BCD, that's also a semicircle. And then if you think about that, to find the measure of a semicircle, CBF right here, that is going to be exactly 180 degrees because it is half of the circle. So anytime you've intercepted exactly half the circle, you've traced around half the circle, that's going to be an automatic 180 degrees. Alright, let's practice a couple of problems. Alright, so here's our first example. Right off the bat, if we pay attention to what they're asking us for, they're asking us for UT in number 1. It's 2 letters, so I know that's a minor arc, which means I want to go the shortest distance to get from U to T, which is that section right there. And I can find the measure of a minor arc by just looking at the central angle here that's across from it. Those are going to be the same. So this is going to be 114 degrees. The next one says ST. So again, that's a minor arc, so that's the shortest distance to go from S to T. This one's a little bit trickier because there's no number here. So we need to think about what we know to find that orange section. If we look, the red section and the orange section together make half the circle. You kind of need to cover up this half the circle to see it, or make this a little bit longer so you see that it's cutting in half. But that's cutting in half, which means that those together have to equal 180. You can also look at the fact that the angles on the inside make the straight line. So we have to do 180 minus 114 to find the orange section, and that's going to be 66 degrees. Alright, the next one they want us to find is ST. SV, sorry. We just found ST. SV is there. To find that section, I can look at the fact that the next section next door to it has a right angle, so I could also add a right angle here. This is going to be 90 degrees. So this guy's going to be 90. Next one says UV. UV is also a minor arc because it's 2 letters, so I'm looking for that green section there. That green section has a right angle in it, so I know that this is also going to be 90. So that's a little practice with the minor arcs. Again, since they're 2 letters, we're going the shortest distance to get there. Now when we hit this next one, this now has 3 letters, so we need to make sure we're looking at the right part of the picture right now. You have to trace those letters in order. So I'm going from V to U and stopping at T. So that happens to overlap the green section and the red section, so we can just add those 2 together to find that major arc. Sometimes that's the better way to find a major arc, and you get 204 degrees. The next one says SVT. So again, we gotta trace the letters in that order. From S, I want to go to V first, so I'm actually going to go up and then come back down to T. Please make sure you stay on the outside of the circle the whole time. Don't try to pass through the middle. There's no shortcuts through the middle. But I'm starting at S, going to V, and then stopping at T. So that is everything but the orange section. So the fastest way to get that purple section is just subtract the 66 from 360. And that purple section would be 294 degrees. Alright, USV. So we start at U. We're going to go to S first, and then we're going to stop at V. So we had to go down and around, so we got to S before we stopped at V. That is everything except for that green 90-degree section, so I can just do 360 minus 90, and I get 270 degrees. Alright, UTS. UTS starts at U, goes to T, stops at S. So it's that darker blue section that I'm looking at right there, this guy right here. That, if you look at, is exactly half of the circle. So I automatically know my answer is 80 degrees. If you wanted to check, you could add the 114 plus the 66. That also is 180 because that's how we found it. So if you take a minute, I'm going to have you try these two, and then I will explain in 3, 2, 1. Alright, so for VT, we are looking at a lot of colors right now. VT is 2 letters, so we're looking at the minor section. We're looking at this little section to get from V to T, which means we're looking at the part that's less than 180. So you're just going to add the 2 minor sections there together. You should have added 90 plus 66, and you should get 156 as your answer for VT. And then lastly, TSU. TSU is going to start at T, go to S, stop at U. I'm using black because I'm all out of colors here. That's everything but the 114, so you can do 360 minus 114, and you should get that that section is 246. Okay? We're just going to try one more here. In this next section, the first thing that they ask you for is PS. So PS is this section here. Now currently we don't have an angle filled in there, but if you think geometrically for a second, if you look at that picture closely, if this part's 25, this other part's going to be 25, so I can fill that in, which means this section's 25. And I'm going to go ahead and put this section as 25 as well. So PS, that short guy at PS, is 25. And then QP, we want the short distance to go from Q to P, is that section. To get that section, I'm using the fact that I see that together the purple section and the teal section make a semicircle. So I can subtract the 25 from 180, and I get 155. So that's my answer for QP. And then RSQ. RSQ says I have to start at R, go to S first, all the way around on the outside before I can stop at Q. So it's that whole pink section there. To find that section, I'm going to have to do 360 minus the section we don't want, the 25, and that would give me that that section is 335 degrees. Alright, QPS. QPS starts at Q, goes on the outside to get to P first, then stops at S. That is exactly half the circle, so I know that's an automatic 180. Alright, again, I'd like you to try to answer these next two, and then I will explain them in the video. So the next one says SQR. Start at S, go to Q first, then stop at R. That's everything except for this section here, which would also be 155. So we're going to do 360 minus 155. Gives you that that section should have been 205 degrees. And then the last section, PQR. PQR says start at P, go to Q, stop at R. That should be exactly 180 degrees because it's half of the circle. Okay, well hopefully those went well when you tried them. You have a class kick to work on first, and then once you're finished with the class kick, you can work on the homework assignment for tonight. Please make sure you turn it in to the assignment on Schoology when you are finished. Have a great rest of your day, guys.